Great, thank you, Steve. And good afternoon. Thanks for the opportunity to speak today. So, as Steve mentioned, I'll be presenting on the status of Lake Huron preyfish. So, similar to previous years, we'll do a kind of a combined presentation here, looking at both our lake-wide acoustic surveys as well as our bottom trawl survey. Just to acknowledge my co-authors here, who've all contributed over the years, and all co-authors on a couple lake reports that are located out in the lobby. Just a brief overview. So just to briefly revisit the objectives for the preyfish assessment program in the Great Lakes Science Center, and then provide a brief overview for the 2014 surveys, and then kind of break the results here into a couple sections. First off, our pelagic species that we assess in the acoustic surveys, and then the demersal and pelagic species that are assessed through our bottom trawl survey. So then I'd like to kind of try to bring everything together here into some conclusions that we can draw on the status of preyfish. So the long-term surveys in Lake Huron to estimate preyfish were sort of fundamentally established to estimate the abundance and biomass for pelagic species as well as demersal prey species, kind of the emphasis being on the offshore preyfish component. And so as we've developed in these long-term time series, we've also been able then to start to evaluate the long-term fish population dynamics. So two primary tools we use in Lake Huron. First off, our acoustic surveys. So we consider these a true lake-wide survey in the sense that we do conduct sampling in the main basin, North Channel, as well as Georgian Bay. The first synoptic survey occurring in 1997, and then 2004 through 2014 has been the most continuous time period. Arguably kind of the hallmark of the preyfish assessment program is the bottom trawling. This is really across the Great Lakes. So really established in the 1960s and early 70s. The emphasis here, or the distinction being, these are main basin estimates as opposed to the acoustic survey. The current time period being 1976 through 2014. So first, just to overview the acoustic survey in 2014. So we was a joint effort. We've done this for a number of years, teaming up with Fish and Wildlife Service and the Spencer Baird, and conducting the sampling a little over a month. The Spencer Baird actually started earlier than the 10th of September here, but so a little bit of increased effort over 2013, roughly 22 transects in 2014, shown distributed here in yellow. And our midwater trawl locations here, sort of, that we collect concurrently with the acoustic transects laid on top. And the survey depths that are encompassed in any given year by acoustic surveys are between 10 and 200 meters. Just kind of a brief overview of the bottom trawl surveys. These are our standard bottom trawl locations in the main basin of Lake Huron. So this survey, pretty typical time frame, sort of mid-October through early November is when we were able to complete this. All 6 ports were sampled, so we have sort of our American ports here, and then the Canadian Port of Goderich down here. The survey depths then encompassed by the bottom trawl survey are 9 to 110 meters. So moving into the pelagic species now. And I'll begin with alewife. So in 2014, we did return to pretty low levels of, I should point out quickly here, we're looking at numeric density on the top panel, and then biomass density, kilograms per hectare on the lower panel. This is going to be the same format for a number of slides here. In 2014, we did estimate lake-wide alewife at less than 1 fish per hectare. As you can see, there has been a fair bit of variability in alewife density in recent years. This is really equated to no measurable increase in biomass, though. So we do see some sporadic alewife production, albeit very low numbers. And so since 2004, alewife have never exceeded roughly 1.5% of alewife biomass lake-wide. So here low for the last decade. 2014 being no different. I think I'm losing my pointer here. Then moving to the bloater, and now making the distinction here that these are young year bloater expressly, and then yearling and older here biomass on the lower panel. We did see low numbers of young year bloater in 2014. This was roughly 24% of the long-term mean. It's kind of hard to see here. This is the 1997 value. So in general, we've seen higher recruitment of bloater. So this young year provides us with a fairly good recruitment index, although quite variable. In 2014, we did see a significant increase in bloater biomass on a lake-wide scale. Keep in mind the standard error around this, the mean estimate here for biomass is fairly large, so kind of an lower precision here for this estimate. Certainly in general, lower biomass of bloater than the 1997 value shown there. Rainbow smelt from the acoustic surveys, also very low densities of young year smelt in 2014. In fact, the lowest that we've seen in the time period. Certainly much lower density overall than 1997. We did see a moderate increase in yearling and older rainbow smelt biomass. This was roughly 60% of the long-term mean. Also, looking at 1997, we can see substantially or significantly lower biomass of rainbow smelt in recent years. However, no real trend here. So that's just kind of the broad picture of total lake-wide density of all fish on the top panel here, and then lake-wide biomass on the lower panel. It was the lowest density estimate we'd seen for the lake here, 40% of the long-term mean as far as total fish density. This is pretty reflective of these low numbers of young year fish that we saw. Typically when we see large year classes, they're obviously very abundant, so that'll kind of ramp up our density estimate. Lake-wide biomass, standing stock, estimated at roughly 44 kilotons. This was 82% of the long-term mean here. Certainly much lower again than the 1997 estimate for biomass. No real trend here again on a lake-wide scale. So we can kind of look at the breakdown by basin in Lake Huron. So just to kind of point out that we did see an increase sort of across the board here. So this slight increase in biomass we saw wasn't driven by just sort of one location in Lake Huron. In Georgian Bay, we saw this increase driven by yearling and older rainbow smelt, primarily in northern Georgian Bay. And in the main basin, yearling and older bloater drove this increase. And in the North Channel, yearling and older rainbow smelt. So just here, just showing the primary contributors to biomass over the time series here. So now kind of transitioning to just the main basin estimates that we derived from the bottom trawl. Beginning again with alewife, very similar to our acoustic estimates, very low density of fish, less than 1 fish per hectare again in 2014. Biomass, again, very similar to the lake-wide estimates. Really, since 2004, we've seen this continued pattern. Very low alewife biomass. In fact, on average, 1% of total preyfish biomass has been alewife. In 2014 here, again, no surprise, less than 1 kilo per hectare. Main basin bloater estimates. We did see a decrease in young of year bloater. However, note that while this was roughly a 50% decrease, this is still roughly 4 times the long-term mean, and really this is due to this pretty long period here of fairly low bloater recruitment. We did see some few pulses here that were concurrent with this building up of spawning biomass. In 2014, we did see a moderate increase in yearling and older biomass, roughly 84% of the long-term mean. And moving on to rainbow smelt for the main basin. So similar to the acoustic surveys, we also saw very low densities of young year smelt in 2014. Roughly close to 50% of the long-term mean. Again, you're way down here as far as fish per hectare, but still 50% of the long-term mean. That's due to this sort of longer period here of muted rainbow smelt recruitment. And yearling and older biomass has really continued to decline in the main basin of Lake Huron. In fact, the second lowest on record in 2014, and roughly 4% of the long-term mean. Kind of a different pattern than we saw when alewife collapsed or became very low biomass in Lake Huron. We've seen this gradual decline over time here in rainbow smelt biomass. Really between 1990 and 2010, roughly 90% of the smelt biomass in the main basin was gone. A little bit more in-depth look at rainbow smelt populations that we've done recently has kind of shed a little bit more light on that. First off, a recruitment study we did a few years ago. And a couple major findings from that. First off, that the decline in spawning stock biomass that I just pointed out here was pretty strongly related to this buildup in lake trout catch per unit effort in the main basin of Lake Huron. And sort of more mechanistically as far as how rainbow smelt populations are functioning, we did see a negative relationship between rainbow smelt stock size and the production of age 0 recruits. So here showing the log ratio of recruits to stock against stock. And just your standard Ricker fit to these data. Again, these are through 2010 bottom trawl data. And just to point out here that some of the largest year classes of rainbow smelt that have occurred in more recent years were at this fairly low stock size. Some other important work recently that's kind of shown a little bit more as far as what's happening within these populations. There's some work by Feiner et al. And really focusing on the 2 lower panels here. Again, the long-term trawl series being represented. A significant decline in the mean length of adult rainbow smelt. Significant decline in the maximum length of rainbow smelt. As well as the length at first maturity. So sort of compounding this decrease in biomass that we've seen over time, these fish are quite different now than they were in the 1970s or 1980s. So now moving to some of the benthic species. First off, the native sculpins in the main basin. Slimy sculpin we've seen very low levels of slimy sculpin for a number of years now. Both these species are historically kind of important integrators of benthic food webs. And with deep water sculpin as well, we see very very low biomass in 2014. Deep waters are historically contributed more to total biomass, as shown here, but again, we've seen this declining trend. Round goby, another species, certainly not a native species, but an important benthic fish. In 2014, we estimated very low numbers of round goby biomass. Based on some recent evidence, looking at some recent diet studies, we believe these estimates are potentially biased low, and this could be for a couple of reasons. It could be, most of our trawl surveys occur on soft sediments, and while we are effective at sampling benthic fishes on soft lake areas, round goby may prefer other habitats. I know this was mentioned earlier, perhaps rocky reef areas. There could also be a substantial proportion of the goby biomass that's located in shallower areas than we trawl, and I'll touch back on goby here in a second. A couple other historically important native benthic fishes, we're also seeing a similar pattern. Trout perch, very similar to slimy sculpin, very low biomass, really for a number of years now. Nine-spine stickleback, certainly more variable over time, but in 2014 we're really seeing this downward trend in biomass as well. So this just sort of a summary, maybe many are familiar with this, just looking at the sort of the lake-wide biomass is generated by the bottom trawl. Roughly 36 kilotons estimated for the main basin in 2014. This is a decline of roughly from roughly 47 kilotons in 2013, mostly driven by a decline in yearling and older rainbow smelt. Certainly, if we look back at previous decades here, we see obviously the fish community dominated by smelt, bloater, and alewife. Certainly a downward trend in recent years as alewife have disappeared. Some positive news here in recent years. We are seeing bloater biomass starting to come up overall in this latter time period. So just kind of to summarize, overall we did see lower numbers of young year fish in 2014. Certainly in the acoustic surveys, both young year rainbow smelt and young year bloater were at very low biomass, or density rather. And kind of an indication here of poor year class strength for these species, potentially related to the very cold spring that we had. Secondly, sort of sounding like a broken record here with this alewife, but they are again remaining near historic low levels. And also our benthic species, historically important food items for lake trout and burbot. A lot of our sculpin, trout perch, stickleback are also at record low biomass. I was asked recently, I was speaking with some anglers, I was asked, is there anything positive? And this was kind of the one positive I would say is that we are seeing a dominance by native species. It is just one species, the bloater. And the final sort of piece here is that is related to overall preyfish diversity in the offshore environment. And really that it's lower than it has been in previous decades. We're seeing roughly 90% of the biomass from the bottom trawl surveys dominated by bloater. Bloater and rainbow smelt make up roughly 99% of the acoustic biomass. So, why is this important? And 20 years ago, fish community objectives that were developed for Lake Huron with a 20-year horizon. So I think this is timely to sort of evaluate this. And here, looking specifically at the preyfish objective for Lake Huron, that being to maintain a diversity of prey species at population levels matched to primary production and predator demands. I think also some language within the prey fish community objective for Lake Huron. I think kind of an important part is this idea of diversity, and so not necessarily in the traditional sense a diversity indice, but just this idea of a broad range of prey species available to predators. So this idea that with some more diversity in the prey base, you're insulating against this year-to-year fluctuation that we see in a single species. So certainly smelt and alewife, bloater have fairly erratic recruitment patterns. So if we look here, this being the bottom trawl biomass, sort of percent biomass, and historically we've seen a mixture of species comprising the offshore prey fish community, pelagic species, and also a contribution here by native benthic species, your sculpins shown up here in pink, smaller but albeit sort of always there. And really we've recently started to see this shift sort of towards dominance by one or two species. Certainly in 2014, with roughly 90% of the biomass from the bottom trawl being bloater, this is certainly the case. Now, to temper some of the concern over the lack of prey fish diversity, some recent work by G. He et al. Has shown sort of kind of balance this, what we're seeing in the prey fish surveys with piscivory by some major predators in Lake Huron. So this is similar to what I just showed, although through 84 through 2010, a shorter time period. And this being piscivory, or consumption by lake trout, Chinook salmon, and walleye in the main basin. And so what we are seeing here is this goby component up through 2010 that is not being picked up here in the bottom trawl survey. So relating back to what I said about some of our potentially catchability of goby and where they're located. So that being said, we still are looking at lower diversity overall of prey fish, relying on probably two to three species primarily in the offshore. And with that, I'd just like to acknowledge the